Right, hello ladies and gentlemen, it's time for your lesson on piecewise functions. So, what piecewise functions are, well, if you turn to this page, this shows you some picture. What does it look like? Yeah, it's like multiple graphs, but on the same one, but you're not drawing the whole graph, and sometimes you got like parts that are like going up and horizontal and down, and sometimes you get some that are quadratic and linear, and you just kind of have a mix of things. Yeah, these are piecewise functions. They're functions made of pieces of other functions. It's not that bad. Let me just show you how it works out. If you're the kind of person who likes having like step-by-step instructions, I tried to make some. Step 1, you're going to split your graph into different sections. Step 2, you're going to plot the points of each function, but don't connect them quite yet. And then you're going to graph each of those, but only in their sections. So you're going to connect up just the part that's supposed to be visible. And then you have to check on the borders. Sometimes you have open circles, sometimes you got closed circles. We'll talk about it when we get there. So if we look at number 1, we have 2 different functions that we're going to graph. And over here, it gives us what part of the domain has that particular graph. And see, you'll notice that these change at where x is -2. So I'm going to come over here to my graph. I'm going to go to -2. And I'm going to draw a vertical dashed line here. Just to kind of be like, okay, this is where things change. And the way you read this is, here's our function. The function is the first option when your x's are less than -2. And then your function is this second option when the x's are greater than or equal to -2. And so basically to the left of -2 is going to be this line, and then to the right of -2 is going to be this quadratic. So if I come over here is going to be a line, and over here is going to be my quadratic, okay? And so let's go ahead and plot the points that make these 2 graphs. And since I have some color options here, I'm going to do this first one in green, and I'm going to do the second one in red, because why not? All right, so let's do this first one. This is a line. It has a y-intercept of 5 and a slope of 1. So I'm going to come over to my graph. I got my y-intercept of 5, 1, 2, 3, 4, 5. Put my dot here. And then my slope is 1. So I'm going to go up 1, right 1, up 1, right 1. But you can also go down and left, down and left, down and left, like this. And I'm putting all these dots, but I'm not going to connect it quite yet. We'll get to the connecting part later. Next one. This is a quadratic. It has moved left 1 and up 2. At least my vertex has moved left 1, up 2. So I'm going to go over here and go left 1, up 2. Here's my vertex. And I know that since there's no number in front here, that my a value is just 1, so it has a normal slope. So I'm going to go up 1, and then I go up 3, and then I would go up 5. On the other side, I go up 1, and I go up 3, and that's as far as I can go. So here's my graphs so far. And notice I have not connected any of them yet, because now I need to figure out, well, which points do I connect? So I'm looking at step 3. So I'm going to graph them, but only in their sections. So my first one is for all x's to the left of -2. So I come over here, and look, this is where I drew my vertical line. This is where x is -2. And so over here on the left side of it is where I draw the line. So I'm going to connect these green points until I hit that border, that little section there, that border of -2. Now I'm going to come back over here to this one. The quadratic exists when the x's are greater than or equal to -2. So I'm going to come over here. Here's my -2 again. So everywhere to the right of it, I'm going to connect those dots like this. And so you may notice I didn't use this dot, and I didn't use these green ones here. And that's because that function isn't present on that part of the graph. So if you're the kind of person who really hates having extra dots, you can erase them, and it looks like this. But I'm going to leave them just so you can kind of see the work there and know where things came from. Oh, I forgot to put an arrow over here. So I put an arrow. And now I need to jump to my last part, which is checking open or closed circles. So much like when you're graphing on a number line, what symbol is here dictates whether you have an open circle or a closed circle. Right here, since this just says less than -2, at the end point here, I would put an open circle. So on my green one, I would actually have an open circle for that part. So the line is open circle. And then my quadratic, since it says or equal to on my domain there, that would be a filled in. So this is closed, and this one is open circles. Okay, so my red one, I would make sure on my border here it was closed, so a filled in circle. This makes more sense, or like it's better to distinguish between the two if they were separate. So like, oh, that did not work out. Here, I'm going to take these things. So let's say my quadratic was actually down here with my graph. It's not, but let me just kind of show you what it would look like. The red would be filled in here, and then on the green one would be open there. And so it would look like this. So open circle, filled in circle at the border there. It just happens that these two functions meet at that particular point. And so the border's kind of whatever there. The line is open, the quadratic is filled in. They just happen to be connected. And so, yeah, that's how you graph a piecewise function. That's it. So really, you're graphing all of the parts to it, and then you just actually connect up the dots in the sections that it says. This has other things it's asking, like what's the domain of this thing? What's the range? Well, you just come over here and look at it. Okay, domains, how far left and right? What are the possible x's? This goes left forever and right forever. So I'm just going to put -infinity to +infinity. Got a nice interval notation there. Range, looking at my range. It looks like it goes down forever and up forever, and it's all connected there. So it's just -infinity to +infinity again. If this line had gone like this, then my range would just go from 2 to infinity. So just be aware of that. Sometimes it's not -infinity to +infinity for everything. Next question is it a function? So remember, the definition of function is each x only leads to one y value. If for some reason you have an x value that has multiple y's, then it's not a function anymore. And that happens if you, for some reason, have a graph that has overlap. So let's say we had these two kind of square root looking things. If I were to look at this x value here, there's actually two different y values. Say it's 1 and 4. That'd be two y values for a single x, and that would mean it's not a function anymore. This one, if you look at any old x value, there's only one y value that goes with it, and so this is a function. Next question is asking if it's continuous. Continuous just means all connected. All connected. As in there's no jumps, there's no gaps in the function. So this one's all connected. Yes, continuous. These next ones here are asking what are the function values at these different x's. Remember, these are supposed to be x's in here, and you have to find the y values that go with them. So if I want to get my function value for x is 3, I come over to my graph, I go over to where x is 3, which is here, and I have to go up and figure out how high up it's going to be. Luckily, I know it's the quadratic, and so I can take this 3 and just put it in my quadratic part of that. So I can do 3 plus 1, and I can square it, and add 2. 3 plus 1 is 4, squared 16, add 2, you get 18. So we got 18. Nice. And the next one's f of -4. So if I were to come over here, come to my graph, come to -4, 1, 2, 3, 4, figure out how high up it is, it's at 1. So you can come here and just put a 1. You could have also taken this x and put it in the line part, since that's where the x's are less than -2. It's -4 here. So you can plug it in. -4 plus 5 is 1. And the next one, what is the function value at -2? This one's a little bit tricky because you do have to pay attention to which one of these gets chosen when x is -2. And the way you can tell is the one that has or equal to on it. So it's going to be this one, which means we need to use the quadratic function to figure out this one. So if you were to plug in -2, you get -2 plus 1, which you square, and add 2. It just comes out to be 3 there. Right, -2 plus 1. Yeah, so you get 3. Ta-da, we did number 1. Takes a little bit of work. It's kind of got these extra questions on it. Just remember, when you're graphing, put the dots down for both, and then just connect over which x values that you're given on your piecewise function. And so there's your first example. When you get to other ones, you can have more than 2 pieces. You can have 3 pieces, and they'll be split over different things. Let's actually kind of walk through this one. We're not going to do this part just for the sake of time, but let's walk through this one. So first things first, I come over here and I'm going to split up my graph into the different sections. So it's changing when x is 0, and it's changing when x is 5. So I'm going to come over here to my graph. It's split in at x equals 0, which it happens to be the y-axis. And I'll come over here to 5, 1, 2, 3, 5. And it's going to change here at x equals 5. I'm going to come over here to my options. So this is a quadratic to the left of 0. So let's put this one in color, we'll put this one green. So I'm going to come over here, I need to graph x squared minus 1. So x squared minus 1 just means the vertex is down at -1. And it's going to go up 1, and then it goes up 3, and it goes up 5. Was it 1? Goes up 5. Like that. And then my next one, I'm going to put that one in red. This is a line. The y-intercept's -2. Sorry, the y-intercept's -1, and slope is 2. So I come down here to -1, slope of 2, goes up to right 1, up to right 1, up to right 1, up to right 1, up to right 1. Okay, does that. And I can go down and left like this. And then my next one, let's pink. We'll make, we already got red. Let's do purple. Put this one in purple. Remember, if it just says 3, that means y equals 3. That's a horizontal line at a height of 3. And so I'm going to come over here. Horizontal line at height of 3. Purple is just going to be this horizontal line going like this. Okay. So there's my 3 different functions. I got a whole bunch of dots on here. You should probably keep track of which one's which. That's why I recommend colors. And now I'm going to connect up just over the section. So for all the x's to the left of 0, I'm going to connect the quadratic, the green one. So I'm going to connect these ones, like so. And now I've reached my y-axis, and that one's done. So I'm not using any of these points. It's not those graphs at all. So now I'm going to do the red part. This is just between 0 and 5, so that's my linear part. And that's going to go connect these red ones. And then my last one is 3, and that's to the right of 5. So I'm just connecting here to the right of 5. All right, so I got my piecewise function connected up. Now I just need to double check my endpoints and figure out where the filled in circles are and open circles. So since this one says or equal to, on this border here, this should be a filled in green circle. The next one, it is open on the end, but on the other side, it's actually closed. So the red one's going to be closed up here, but it should be open here. So I'm going to make this big circle. And then for the purple one, it's open there. So I'm going to come over here and make sure I have an open circle on the end of that one. So ta-da, I have graphed another piecewise function. So now that you've seen that, we're going to jump to the last section, which it gives you a piecewise function, and you have to write it out and write out the equation for it. So we're going to look at 11. It has 2 parts. This one's can be a little bit confusing, but it does have the pattern here of going up by 1, goes up by 3. So this one's a quadratic. And then this here is a line. So that means we're going to have those two parts. You probably don't have this part here on your thing, so we're not going to worry about it because, copying and stuff. But I'm going to write out my piecewise function. F of x equals, and you can do this squiggle bracket thing. And let's do the quadratic part. I can see that this goes up 1 and up 3. So it lets me know that this is my vertex. So if I want to write out where my vertex is at -3, 0, I need to take x, and I move it left 3, and that's by adding 3 inside the squared part. And since it didn't go up or down at all, I'm not going to have a plus number here. You don't need that because it's just on the x-axis. So here's my first one. And then my next one is this line. Well, you got to figure out your y-intercept here, which looks like 2.5. So I'm going to have that plus 2.5, or you can have it as 5 halves. And then you have to figure out your slope. Well, to figure out slope, I'm going to use like definite points I can find, which are these two. It looks like it goes down 3 and right 2. So I'm going to write out x. Down 3, right 2. So there's my slope. And now we have to put the x section, like for which x's this exists. Well, for the first one, it's actually just between these two x values. So that's between where -3 and -1. And it's really hard to tell whether these things are filled in or not. It looks like the left ones, it looks like they're all filled in. So I'm going to have this be or equal to. And then the next one here, it goes between -1 and 3. And this one is filled in, so I'll make sure to put that. So -1 to 3. And this part's a little bit tricky. You can't have 2 or equal to's on a single number. So if I say this one's or equal to on -1, I can't have it here as well, because that'd be a conflict between them, right? Because if you were to look at where x is -1, which function is it? If you have or equal to, it's both, which makes it not a function anymore. And so we're going to leave this one as just less than to know which function to use right at -1. But there we go. Wrote out our piecewise function. And there you go. That's what's going on the back page here. Just break it up into different sections. Write out the equation of the lines or quadratics, whatever's there. And there you go. Good luck.